Welcome, students. This is Instructor Cho. I'm going to be learning calculus with y'all. This is my first time teaching this class, and I haven't done calculus in a while. So sometimes I'll record these like long one takes where I'm just thinking aloud as I'm doing my work. And hopefully, and the intent of this is to kind of guide you if you're like not sure about something. So it's not meant to teach you. It's meant to kind of point you the right direction and kind of like add a vocal aspect to the answer key in case you're not sure about how or why I did something the way I did. Okay, let's start. Things we need to know to be successful this year. So this looks like it's going to be some solving stuff. And remember, solving means you are identifying all possible values of x that make a true statement. And usually to solve, we have to isolate the x value. So to isolate the x value, what we are going to do is we're going to add 2 to each side, which is then going to give me, oh yeah, and since I'm trying to post this, I'm trying to be somewhat neat. That's going to give me 5 natural log of x minus 2 is equal to 30. Divide 5 from each side, which is now going to give me natural log of x minus 2 is equal to 6. I know natural log is another way of saying log base e of x minus 2. Like natural log is just log base e. So that's going to give us 6. You don't have to write that work down if you don't want to. That step. Then I'm going to have e to the power 6 is equal to x minus 2. Add 2 to each side to finish the problem. E to the power 6 is equal to x. No! E to the power 6 plus 2 is equal to x. Okay, on to the next one. I'm going to change my color because I just feel like it. Okay, so solving for x, I'm going to subtract 4 from each side, which now gives me e to the power of x minus 3 is equal to 16. Can't have x in the exponent to solve, so I need to isolate it. I know logs is just a way of rewriting exponents and stuff like that. So let's do that. That's going to give me log base e of 16 is equal to x minus 3. And log base e is the same thing as ln, natural log. So I'm now going to have natural log of 16. And I know I'm going to add 3 to each side. So that's plus 3 is equal to x. Next one, 3 over x minus 4 minus 2 over 3x is equal to 0. So LCD is a way to go. I love LCD. I don't really like multiplying the variables out because I might make mistakes. So LCD is clearly 3x times x minus 4. This fraction over here needs to have a 3x because it has x minus 4 already. So that gives me 9x then. Minus, and then over here, this fraction needs an x minus 4 because it already has a 3x. So that's going to be minus 2 times x minus 4 over, and I can put that as one fraction because the point of this was LCD. So all of that is meant to be over, and we're going to have x minus 4 times 3x. So now in the numerator, we have to distribute. So that's going to give us 9x minus 2x plus 8 over. And then in the denominator, I'm going to have distributed 3x squared minus 12x. I probably shouldn't have distributed in case I could cancel things out later. But oh well, I'll pay for that mistake later if I have to. Please don't do that. Please don't do your stuff the way I'm just doing it right now. Okay, so 9x minus 2x equals 7x. So we have 7x plus 8 over 3x squared minus 12x. And that's going to equal to, nothing's going to cancel out. So actually, that's the answer right there. Next one, tangent of x minus 3 is equal to negative 4, and they give us a restricted domain in radians, so I should be in radians, which are unitless. I'm going to add 3 to each side. Tangent of x, whoops, not tax, tangent of x is equal to negative 1. Solving for x, which means I'm going to use inverse tangent, aka arc tangent, if you like to call it that way, if you're more Greek. Then I have this over here. X is going to be the angle because inverse tangent provides angles as outputs. So I need the ratio to be negative 1. Tangent is positive in quadrants 1 and 4, or 1 and 3. So I already know we're not going to use 1 and 3. Tangent is negative 1, 2, and 4. So I'm going to look here. The restricted domain is 0 to pi, which means only quadrants 1 and 2 are eligible for my answer. So there's only one place that overlaps perfectly, and that's quadrant 2. So I'm going to use the quadrant 2 version that will give me negative 1 as the output, which I know is 45 degrees. So the quadrant 2 version of 45 degrees in radians is 3 pi over 4. And it can't be anything else because of the restricted domain. Okay, here's another one. 1/4 times sine cubed x times cosine of x is equal to 0. This looks crazy, but we're multiplying everything, which allows us to use zero product property. Cosine of x is going to equal to 0. Solving for x then is going to give me x is equal to the inverse cosine of 0. Cosine is a horizontal length. Horizontal length is supposed to be 0. When do we have a horizontal length of 0? When we're on the vertical axis, which is 90 degrees and 270 degrees. We're in radians, so that means we can only be in pi over 2. And then over here on the other one, we have also sine cubed x is equal to 0. When you cube root something, it doesn't change the sign. So I'm not worried about extra things that can happen. Now I'm going to do the inverse sine, which is going to put us in a vertical length of 0 because sine is vertical. And vertical length of 0 happens on the horizontal axis, which is both the 0 and pi. And we're allowed to use both of them because it is a inequality sign with the equal to. Okay. Next part, x squared minus 3x is equal to 5. Let's subtract 5 from each side. This is not factorable, I can tell because I've done thousands of factoring problems. So from now, I'm going to do quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. Simplifying that more, I get x is equal to 3 plus or minus the square root of 9 plus 20 over 2. X is going to equal to 3 plus or minus the square root of 29 over 2. And root 29 doesn't simplify, so that's why we can't go any further. Let's change colors. Let's see. I like pink. Simplify the following expressions. Okay, so I can see that this is factorable already. X minus 5, x plus 1. And again, it's because I've practiced this so many times so slowly that I can now do it quickly. And then in the denominator, we got x plus 5, x minus 5. I can see that what's going to cancel out are the x minus 5s, which is going to give us x plus 1 over x plus 5 as our simplified form. You should state your exclusions when you're doing simplifying. So I should have x cannot be negative, or x cannot be positive 5, because that's what we cancel out. Next one, we got 4 over x minus 5x over x minus 3 plus x cubed. LCD is again the way to go. LCD is x times x minus 3. So that's going to give me 4x minus 12. I already distributed the 4 with the x minus 3. And then I'm now going to have minus 5x squared plus x cubed times x squared minus 3x, because x cubed has none of the denominators, so we have to put it all together. And all of this is going to be over x squared minus 3x. When I simplify this even more, I'm going to have to go into the tangent space. That's going to give me, in order of standard form, because that helps us organize our work, x to the power of 5. Then we're going to have minus 3x to the power of 4. There's no third powers. Minus 5x squared. Plus 4x. Minus 12. And then all of this is going to be over. And since we're fully simplifying, we have to multiply everything out. So that gives us x squared minus 3x. So this is not going to simplify further. And if you need to check your work as you're doing it, I strongly recommend using Wolfram Alpha because it'll help you check your answers as you're doing your work. Okay, now let's do number 9. Tangent of x times cosine of x over cosecant of x. Let's simplify it down, or break into its ingredients. So you got sine of x over cosine of x times cosine of x over 1 over sine of x. So I can see right now that the cosine of x are going to cancel out. And then I know the sine of x is going to work with that sine of x, because when you divide a fraction, you are going to do the reciprocal and multiply. So the denominator and the denominator is now going to become a numerator. Okay, so that's going to give us sine squared x. Next, we got 8 to the power of negative 4 over 3. Okay, so negative exponents are responsible for reciprocals, aka inverse. So I'm going to now have 1 over 8 to the power of positive 4 over 3. Now, I could try to work with this here, but I realize 8 can break down. And it might be easier to work with the more basic version of it. So it's not going to give me 2 to the power of negative 3 to the power of 4 over 3. Now, if you remember, you multiply exponents together when they're powers of powers. So that gives us 2 to the power of negative 4, because the 3's are going to cancel out. And that's 1 over 16. You got the 6th root of 27 to the power of 4. Okay, so 27 can be broken down to a more basic version of itself. So we're now going to do 3 to the power of 3 to the power of 1/6. So 1/6 represents the 6th root. All this to the power of 4. Now, I'm going to start with PEMDAS. So inside, 3 into 1/6 makes 1/2. 3 to the power of half to the power of 4. And then that's going to become 3 squared, which is going to be 9. We don't have to worry about any plus minus situations because we're working with the actual number. Plus minus situations only happen uncertainties, aka variables. Okay, write the equation of a line given the following information. There's 3 valid forms of a line. Point slope, slope intercept, standard. My favorite, unbiased, is point slope, which is a valid form of a line. So I'm going to use that for the most part, unless I think there's a better one. From here, find the slope. Change of y over the change in x. 25 minus 5 is 20. Negative 2 minus 3 is negative 5. So that gives you a slope of negative 4. So now I got 2 options for answers. I could write y minus 5 is equal to negative 4 times x minus 3, which is totally fine to write down because that's a valid form of a line. It's point slope form. You could also put in negative 2, positive 25, and that will, like, negative 2 comma 25, and that'll be another version. Okay, this one over here. Same thing. Slope, change of y over change of x. So that's negative 8 over 0. I can't divide by 0. That's undefined. That tells you it's a vertical line. Another way to know it's a vertical line, the x coordinates are exactly the same, which means these points stack on top of each other, stack on top vertical movement. So x is equal to 3 because all of the x coordinates are going to be 3 on this line. And lastly, slope is 1/3, coordinate is 2 comma 3, point slope form. Easy. So you got y minus 3 is equal to 1/3 times x minus 2. Sketch the 2 equations on the same coordinate plane, then label the points of intersection. Okay, so let's just do a sketch. Y is equal to x plus 1, y is equal to 4 plus 3x minus x squared. That's a parabola. Okay, let's change colors. Let's go purple. Okay. So let me make a sketch of a coordinate grid. By the way, I'm hoping you're going to do this on graph paper and do in much more detail than I'm about to do it right now. X plus 1 looks about like this. Again, I'm hoping you're doing it in much more detail than I am right now. Okay, then we got parabola 4 plus 3x minus x squared. Let's go ahead and find the vertex. Negative b over 2a. Negative 3 over 2 times 4. That's negative 3 over... Wait, not 4. Whoops. I bamboozled myself. A value is not 4. A value is the number in front of x squared. So in this case, it's negative 1. So negative 3 over 2 times negative 1, which is positive 3 over 2. Okay, that's the x coordinate. Let's find the y coordinate. Oh, we got to plug this in. Okay, wrote it out. 4. Okay, so 3 times 3 over 2 is 9 over 2. Add that to 4. That's going to be 17 over 2. 17, so we got 17 over 2. And we have to subtract that by 9 over 4. Oh, LCD is 4 now. So it's 34 over 4 minus 9 over 4. 34 minus 9. Yeah, it's taking me this long. It's 25 over 4. So you have 25 over 4 as your y coordinate, which is about 6-ish. Okay. So if I graph the vertex, it's probably good. I'm just going to guess. It's about here. A value is negative, so it's going to open downwards. Probably something like that. Let's solve. Because we have to find the intersection points. And when you find the intersection points, you just solve your system of equations. I do see a substitution opportunity. So I'm going to have x plus 1 is equal to 4 plus 3x minus x squared. Okay, let's solve. Move everything on one side. 0 is going to get equal to negative x squared plus 2x plus 3. I personally like to have the a value be positive. So now I can see that this is factorable. X minus 3 and x plus 1. So our x coordinates for our intersection points are 3 and negative 1. Then you have to plug it back into one of your equations to get the y value. So I'm going to do like 3 plus 1 is 4. So 3 comma 4 is one of the points. And then I have negative 1 plus 1 is equal to 0. So negative 1 comma 0 is another point. So that coordinate is 3 comma 4. And this other coordinate over here is going to be negative 1 comma 0. Great. Use a unit circle. Okay, good. If you have a unit circle down the way we need you to, you should be able to do it pretty easily. Like it's multiplication tables. Sine of 3 pi over 2. That's 270 degrees, negative 1. Cosine 11 pi over 6. Pi over 6 reference angle 30, 60, 90, 1 root 3, 2. Opposite side is 1. We want the adjacent side, so that's root 3 over 2. It's positive in quadrant 4. If you don't quite remember how to do this, draw your quadrants. 11 pi over 6. Reference angle pi over 6. That means this is negative 1 because it's in the quadrant 4, negative y values. Root 3, 2, adjacent over hypotenuse gives me that answer. Okay, tangent of pi over 6. Opposite over adjacent in quadrant 1. That gives me 1 over root 3. But we need to rationalize our denominator, so that gives me root 3 over 3. Functions. F of x equals x squared minus 2x. G of x equals 3x plus 4. H of x equals f of g of x. What is h of 3? So h of 3 means that I need to plug it into this, because h of 3 input. So that gives me f of g of 3. G of 3 then is 3x plus 4, so that goes in there because it's, a straight up substitution. F of 3 times 3 plus 4, which is f of 9 plus 4, which is 13. Ugh. Okay, so we got to do f of 13, which is we're going to do some squaring. X there. So that's going to now give me 169 minus 26, which is going to give me 3 for 143. And again, if you're not sure what I did, the f of 13 means I plugged 13 into my input value. So 13 squared gives me 169. Negative 2 times 13 gives me negative 26. What is h of x minus g of x? Okay, so h of x is, this could be a long one. F of g of x minus g of x. Let's do our substitutions now. F of g of x is 3x plus 4. So we're doing f of 3x plus 4. And we're going to subtract that by g of x, which is 3x. Let me show you the work. 3x plus 4 in parentheses because we have to make sure we distribute that negative sign. So that's going to give us over here negative 3x minus 12. And then over here we got f of x, x squared minus 2x. So that's going to be 3x plus 4 squared. And then we have a minus 2x. So it's minus 2 times 3x plus 4. 3x plus 4 squared is 9x squared, plus 2 times 4 is 8, times 3 is 24x, plus 16, minus 6x minus 8, minus 3x minus 12. Let's simplify. So 9x squared is only squared. Then from here, I am seeing that we have 24x minus 6x, so that's 18x, minus 3x, that's 15x. Along with that, I am also seeing that we have 16 minus 8, which is positive 8, minus 12, which is negative 4. That's what it is, fully simplified. Okay. Sketch the following parent graphs. I mean, if we were to just sketch it, line. I would want you to do it in more detail, but just so you know. Parabola cubed is like one of these things. Y is equal to root x, so that's a square root graph. Tapers off. Fly in the curve. Ha ha ha. Okay, anyways, absolute value. Diagonal lines that meet at 0, 0. 1 over x, that is one of these where you have two hypotenuses. No, two asymptotes. I don't know why I said hypotenuse. One of the asymptotes is going to be vertical here because of the 1 over x part. The denominator can't be 0. And the other one's going to have a horizontal asymptote going across x equals 0, the vertical line, or horizontal line, because your denominator's degree is higher than your numerator's degree. E to the power of x. That's the same thing as an exponential graph because it's like 2-ish to the power of x. So it's going to look something like this. Sine of x creates a sinusoid, aka the Rebecca Black hands on her famous music video Friday. So it's going to be like, and it just goes on like that forever. Y is equal to cosine of x. It's the same thing because cofunctions let you know cosine and sine can be written as each other, just shifted over by 90 degrees. So, or pi over 2. So instead, it's going to be like, and then it's going to be like that. Okay, going on forever. Next, we got y is equal to tangent of x. That one's different. You got asymptotes going on over and over again. Tangent of 0 does exist. Tangent pi over 2 does not. So our graph is going to start out by doing this. And then you're going to have a vertical asymptote at pi over 2. And then it's just going to repeat that pattern again in perpetuity, just like your life. It's going to exist and be repetitive in perpetuity. Okay. Find the following limits. I haven't done limits in so long. Okay, let's see if I can remember. X squared minus 4. I'm gonna. Is this? No, it's not that. I think it's. No, it is that. It's meant to be this. Okay. So when you do limits of x squared minus 4, we're going to have a graph, parabola, down 4 spaces. So it's gonna look like this. Okay. So when you plug in 2, you get 0. So that's the corner we're at. And when I approach from the right side, I reach a y value 0. When I approach to the left side, I get a y value 0. So limits about what y value are you approaching? What output value are you getting to from both ends? And from both ends, we're getting to 0. So this is equal to 0. And then for this over here, limit of x approaches 3 of x squared minus 9 over x minus 3. Okay. Remember that when you simplify this is side work. This is going to give us x plus 3, x minus 3 over x minus 3. When you cancel a numerator and denominator, it means that there's no longer a vertical asymptote you have to worry about. The canceling makes it a whole. So that's going to now give us the basic line x plus 3. So if I were to graph this, it pretty much looks like that. It's a line x plus 3, but because we cancel out the x minus 3 part, we have a hole at x is equal to 3. So there's a hole here at the 3 coordinate. How do you find the y coordinate? Plug it into the most simplified version of that equation. So that's going to give us 3 comma 6. There's a hole. Okay, now limits. Approaching 3 from both ends. So going from the right side, yeah, that looks like a y value 6. Going from the left side, y value 6. Now, yes, the point does not actually exist, but limits is not about whether something exists or not. It's about trends. Where do things look like they're going? They're going to 6. Therefore, the answer is going to be 6. It's not like Mean Girls when the limit does not exist here. This one, the limit does exist. Okay, we got answers here. Let's go ahead and check the answers. So number 26, 21, 6, and 0. Okay, good. We're good. Okay. Sketching a graph, not there. Yeah, you can use Desmos. 19, we got B, 9x squared plus 15x plus 4. Yep, we're good. A, we got 1 to 43. We're good. 18, we have root 3 over 3, root 3 over 2, and negative 1. We're good there. 15 and 16. So if I look, or 15. If I look at 15, I have negative 1 comma 0, 3 comma 4. Negative 1 comma 0, 3. Yep, we're good. 12 through 14. 14 is 1/3 x plus 7. Okay, so they didn't slope intercept form, but point slope form is totally fine. Don't forget that. So that's good. I'm pretty sure. I'm pretty confident these are correct because point slope form also allows for less errors. Okay, less likely to make errors. Sorry. Going on now to 7 through 11. So number 11 is going to be 9. We are good. 10 is 1 over 16. We're good. Sine squared x, we're good. X to the 5th minus 3x to the 4th minus 5x squared plus 4x minus 12 over x times x minus 3. Okay, we're good there. I do think the denominator should be x squared minus 3x if you're fully simplifying. Number 8 is going to be, well, that was 8. Number 7 is x plus 1 over x plus 5. Good, and we include the exclusions, so even better. Okay. 3 plus or minus root 29 over 2. We're good there. We have 0 pi over 2 pi. Yep. 3 pi over 4. Yep. 7x plus 8. Oh, wait a second. Did I make a mistake here? This is saying the answer is negative 8 over 7, but I have an expression. Oh, I didn't solve. I didn't finish number 3. Okay. Let's finish number 3. And if earlier you're like, Instructor Cho, you didn't finish number 3, you are correct. And where were you on this day of July 31st at 1:50 p.m. when I am making this? Okay, anyways, not your fault. It's my fault. So I got 7x plus 8 is equal to 0. I forgot that the whole thing was equal to 0 because guess what? In my work, I forgot to write it. If I had written it every single time, this would not have been an issue. Okay, so I'm solving. Now, the denominator is not going to yield me any answers that are going to work to make a true statement. But the denominator is valuable because it tells me what the numerator cannot be. Based on the denominator, we cannot have x equal to 4 or x equal to 0. So if I get those, I throw those answers away. Numerator, when you divide two numbers to make an output of 0, you always divide the numerator. The numerator has to be 0 for that to be true. So we're going to use that property and make 7x plus 8 is equal to 0. 7x equal to negative 8. X is equal to negative 8 over 7. That is the answer, and we line up, so we are good. Okay. 2 should be natural log of 16 plus 3. Yep, we're good. And 1 should be e to the power 6 plus 2. We are good. Excellent. This is all correct. I hope this is of some use to you. I hope you neither enjoyed it nor hated it. I hope this just is.